In this video, we're going to take a look at EIGRP and some of the filtering techniques that are available with it. Now, at this point in time, you should be pretty familiar with passive interfaces, prefix lists, standard and extended ACLs, offset lists, and administrative distance. The ones that I'm going to be a little bit more specific to are going to be per neighbor AD route maps, per neighbor prefix limits, and redistribution prefix limits. The drawback to that is some of these things we can't use, at least in our examples here, because of the fact that we don't have everything fully set up yet. So like redistribution prefix limit, we're not going to be able to do that because we're not redistributing anything at the moment. Same thing with per neighbor prefix limit. We could do that and say we want to prevent too many routes from being propagated from 21 to 16. We could do that. So that's pretty much exactly what that's supposed to be. Now per neighbor AD is going to work similarly to the way that RIP does, where you can specify the AD for a particular neighbor, and we'll take a look at that. But the passive interface literally is going to be going to router 16. We're going to go show IP EIGRP interfaces, and we have gig 1/0, and we have two peers. If you go up to interface gig, or I'm sorry, you type in router EIGRP1 and type in address family IPv4 A1, and then type in passive interface, or I'm sorry, topology base, passive interface, AF interface, gig 1/0, and type in passive interface. What's going to end up happening is it's going to drop all control plane traffic. Anything EIGRP will be dropped. So let's just do it and see what happens. EIGRP goes down. That's a passive interface. I mean, congratulations, we just took down the network. So we're going to Control A and type in no, and go from there. It's important to know what it does. That's like the main concern. I don't need to know how to. I don't need to implement that because I already know what it's going to do. Same thing with the prefix list. If you were to drop out and type in IP prefix list, prefix dash list, EIGRP. Actually, let's do this. Show IP route. What are we learning in here? I don't want to learn in this route right here, the 223 route. So I'm going to go to global config and type an IP prefix list, and I'm going to say the name is going to be, we'll say R21 underscore 223 underscore route. We're going to say is going to be deny, and then the route. So we're going to say it is this guy right here. And we're going to say hit enter, and then we're going to go to router EIGRP 1, address family IPv4 autonomous system 1, and then we're going to type in distribute list under the topology base. Type in distribute list. We're going to say prefix. We're going to say the name of the prefix list is going to be this guy, and we're going to say in. Now we can be specific and say filter incoming address updates based on a gateway. Now what that means, and we're going to show you what this means. So if we do a show IP route again, we should not be learning. Okay, there it goes. It resynced. So, you know what it might be doing? It might, I might have denied too much. What the gateway would mean, if let's go to 21 since this is broke at the moment, we're going to say show IP protocols. It's important to know where to find this. The gateway is going to be the router that advertised the route to you. So that's going to be the IP address you're going to use to get to the destination you're trying to reach. So on 16, we're going to say the up arrow, and I guess we're denying too much. Let's show IP prefix list. We only have one in. We have one entries. Oh, you know what the problem is? I bet you any money is because I'm not doing a permit any. So let's do this. Let's go back, config T, and we're going to say do show. That's what the problem is. Do show run pipe section prefix. we'll do that. We'll grab the prefix list and we're going to tweak it. So we're going to say, we're going to grab this guy and we're going to say sequence 10 and we're going to say permit and we're going to say 0.0.0.0/0 LE32, so less than or equal to 30/32 LE32. So that means this is going to mean everything. We're going to hit enter, and so we should have in a couple of seconds here, because it's the distribute list is already pulling the prefix list, so we should here in a couple of seconds get it resynchronized, and then type a do show IP route, and we should have those routes in, but 223 is now gone. So I made the mistake in RIP doing the same thing where I didn't go in there and specify. So now if we do this, we do a show IP prefix list. We have the two statements in here. We have this one that is catching the route that we don't want to have come in, and then we have another sequence number that's coming in. It could be sequence 6, it could be 10. By default, it goes in increments of 5. So we need to specify all other traffic because we're blocking everything. So now we're denying the 223 in. So that's what the prefix list. Pretty straightforward. Now the benefit to that is the prefix list is going to be for routes and lengths. So if we want to deny a particular route from being installed in the routing table, that is one of the benefits of doing this. Now if we wanted to filter, you could consider this to be control plane, because the EIGRP process is advertising that to you. Standard and extended access lists, that is data plane. The difference between control plane and data plane at this point in time, control plane is going to be your routing protocol, the router to router traffic, saying that it's R16 is talking to R21. So it's going to be the control plane controlling what's going on the router. The control plane directly affects the data plane. So if the control plane is blocking a particular subnet, then you won't be able to advertise that route in. So right now, that route was coming from, originally, was coming from router 21. So now router 21 can't advertise that route. But if we were to advertise 224, it would work just fine, because we're only matching on this guy right here. Now, the main difference between this is if we wanted to block something that was in the data plane, an ICMP echo, a TCP SYN packet, a port number. If we wanted to block telnet, we could do that. So it's actually a great idea. For now, we're going to block telnet in from router 21. So what we're going to do is we're going to go to show run pipe section line and see what we have configured for line. Okay, so I should be able to from 21, I should be able to telnet to show IP route. I should have router 16 in here, which I do. I should be able to telnet to 10.100.16.16. Okay, so let me go to 16 and type in a config T and type in no login on this guy. Let's type in enable secret is actually let's do this. We'll type in username is Rob, and the secret is going to be Cisco. Then the privilege level, privilege level is going to be 15. The secret is Cisco. So now we should be able to go to 21 again and do this ping. It should open it up. Oh, hold on a second. We didn't go to 16 and say login local, did we? Nope, sure didn't. We don't have. It's just login, but transport input. So we're gonna type in line VTY 0/4 login local. Try this one more time, and then we should be able to hit this up. And now we're Rob, and we type in Cisco, and then we're at enable. So we should be able to telnet in. Now what we're going to do is we're going to go to router 16, and we're going to go to global config. We're going to type in IP, or we're going to type in access, a standard access list. We're going to deny. Well, see, I got to be careful with this because a standard access list is going to be anything coming from a particular source. So we're going to type in access list 1, and we're going to deny. And then what do we want to deny? So we're going to deny what do we want to deny? We want, and normally what you would do is you would deny a single host from accessing something. So we're going to deny router 22. So we're going to deny host, and we're going to say we're going to deny 10.1.126.22, and we're going to hit enter. Now we can type in interface gig 1/0, type in IP access group 1 in. Okay, so that's going to drop our control plane. Because what's going to happen is there's going to be a, and I should have put a access list 1. See, I just dropped the control plane. So exit out of here. Access list 1 permit IP any or permit any. Because I don't want to drop both connections. So by doing that, we're going to get 21 back up. So we do a do show IP EIGRP neighbors. We're only paired with router 21 now. So I'm going to go back to where I'm going to go to interface gig 1/0 and take that off. So I'm going to type in no IP access group 1 in. Okay, so we have our adjacency back up, which is a good sign. So that means everything, pulling the access group off, pulling that ACL off, fixes that problem. So now what we want to do is we want to make sure that we're going to create an access list that denies ping from router 21 going to R16. So what we have to do is we have to exit out of here, type in IP access list, and we're going to type in, you could name it if you wanted to, but we're going to say extended, and then we're going to say the name is going to be telnet, and then we're going to question mark, and we're going to hit enter. And then we have our what we want to make it. So we're going to say we want to deny TCP question mark from we're going to get specific from the host of 10.1.126.21. So this is the source of the telnet going to the host of 10.1.126.16 EQ23. Okay, so that's going to block telnet, but we also want to have another type in a permit IP any. So it's going to allow any other type of traffic. So this means I'm going to deny TCP from here as long as it's coming from the well-known port of 23. So we're going to go to interface gig 1 or type in line VTY 0 space 4. We're going to type in access class, and we're going to say what's the name of the access list. We're going to type in telnet, and then we're going to say in. Now you can also do outbound. So you could say I don't want to permit anything in. So we're going to go to 21, and we're going to say we exited it out. Now we're going to try to do that telnet again, and now it's we're on 21, right? Did I type it in correctly? Access list 10.1.20. Oh, you know what it is? I think I might have to do coming host 23, 223, so I think I have to do it two-way. So we're going to go to, we're going to type in this guy and hit the up arrow a couple times here. And we're going to go to the end of the line. We also have to type in this guy, and we're going to say 23. Actually, let's go to the end of the line and whack some of the stuff out of here. EQ 23 question mark 23, I should say 23, and then we're going to say host, and we're going to say 10.1.126.20 or 16. I think that might help. So 21. Okay, so exit, and then if we do this again, why are we being permitted? What is going on here? Why do we do show access list? from the source to the host. So this is the source, this is the destination, telnet. Interesting. Why is it not working? Deny TCP host. And we're saying anything from... Oh, wait a minute. I think this is why. I think because 16 is not the one sourcing it, so we have to do this around. So we'll type in... Can we type in sequence number... we'll say 8, and we're going to copy this line of config. I'll type in no 30. So I'll type this to show access list. And we're going to say, was it sequence number do we have to type in? 8, and then deny TCP host, and then 10.1.126.21 EQ23 to host, and then 10.1.126.16 enter. So that should do show access list. Alright, so there we go. That should be what we need. 21. So we're going to say... So it's still working. Why is it... That is weird. Why is it doing that? I don't get it. We're sourcing it from... Maybe because the destination is this. Okay, so let's exit out. Alright, so we're going to say... we're going to telnet to 10.1.126.16. No, that's not doing it either. So what does 16 see? It doesn't see, it's not even triggering. So let's just do this. Let's just go to IP access list. We're going to type in, just say 5 and deny TCP any. See if that fixes it. And alright, so let's see if that fixes it. And we're going to go to 21 and exit. Control-Shift-6X on that guy. And then do it again. We're going to telnet. Okay, so now it denies it. Okay, so it's... So basically, you could say... The idea was to do basically go from the gateway. And for whatever reason, this is not... doesn't like this. So if we were to do show access list, so now we're catching something here. So it's deny TCP any. Let's try doing. Type in. Let's do 5. Let's do 4. Deny TCP from any source. Well, actually, let's do from 10.1.126.0.0.0.255, and we're going to say EQ23. No, we'll just do this, and we're going to say any, and then EQ23. So that's all we should have to type in. Alright, so we have that there. We're going to go back to 21, and we're going to say telnet, and now the connection's refused. Go back to 16 and see if that triggered. Okay, that triggered. Okay, so it's basically saying anything. So now let's get a little bit more specific. So sometimes, and I've struggled with this my entire career, where access lists, I think I know exactly what the syntax should be, and I screw it up somehow. So we'll type in no 4 and go up. So 4 is now gone. So now we're going to deny. So 4, we're going to type in deny TCP any, or from 10.1.126.21, and we're going to say we'll say host. And then we're going to say to host, and this was to any. And we're going to say any EQ23. Alright, so that's there. Now we're going to go back to 21, and we're going to say, okay, that's denied, so now we're going to go to 16. And basically what I'm doing is I'm just walking it in. I'm trying to get as close to it as I can. So now we got the right one. So now it's, we're going to be hitting, we're going to try this one more time, but instead of doing this, we're going to say no 4. And we're going to hit up, we're going to say go back up here, or go down, go to the beginning of the line. We're going to whack this guy out. We're going to say 4 again, but we're going to get a bit more specific. We're going to say host 10.1.126.16 EQ23. Now you're like, okay, you've already got that configured right here. You are correct, sir. So we're going to punch this in and go to 21, and we're going to try this again. Connections refused. Go back to 16, and then do show access list. And now this is, I'm sorry, I should have hit. Yeah, 4's not even picking up anymore. So we'll say why is it not showing up? Alright, so we'll type in 4 and deny TCP host 10.1.126.21, and we're going to say host 10.1.126.16 EQ23. Yeah, it's not showing up. Oh, because the 10's already there. So we're going to type in no 10. Alright, now 4 shows up. Because we had one that we had a conflicting ACL. That's why it wasn't working. So we're going to go to 21 again and try. And now we're getting connection refused. We're going to go back to 16. Show access list. And okay, so this is not working. This does not work. So we obviously have a problem to where this is not going to be the issue. It's actually catching on the one below it. So the TCP any. So that obviously doesn't work. So we would have to type in no 4, and we'd have to type in 4 again, and we would have to type in any 4's back, and then any EQ, and then we're going to go back to 21 and go back to 16 to see if it catches it, and it does. So we type in no 5, no 8, no 8. So now we have that. So now we should have what we need. And then go back to 21, and then we try it again. We have no telnet to that. So that shows that we have to, and that was kind of stunk that we had to go do that in, but at least it showed. I didn't know that, to be honest with you. I thought you could have just done that. Now I know from a distribute list perspective, you can strip things on the gateway, doing like administrative distance and offset lists and things like that. You can do per gateway, and then you can modify the AD in the same respect. So let's go take a look at that. We're going to go and see on 16. We want to do a do show IP route, and I want to deny this route from 22. Okay, so I want to deny that route from 22. Or actually, you know what? I'm going to. We're not going to do that. We're not going to deny it. What we're going to do is we're going to use an offset list to increase this value to be higher. So we're going to type in router EIGRP 1 address family IPv4 address autonomous system 1. We're going to type in is it topology base? Yeah, topology base. And then what we're going to do from here is we're going to type in the offset list is right there. So we're going to type in offset list, and what the offset list is going to be. Now, we don't have a prefix set up yet. So what I have to do is I have to type in offset list, and we're going to say R22 question mark, and then in, and then we're going to say the offset is going to be we're going to say 200, and then we're going to say the interface that we had to set it on is going to be on gig 1/0, gig 1/0, and then we're going to say, so we're going to do that. We're going to hit enter. Now we have to go to now we look at do show IP. Let's see, do show IP route. So nothing has changed yet, right? So it actually went into resync, and it doesn't change anything because we haven't modified anything. So once we create the prefix list to call that, we're going to take this and we're going to increment up by 200. So then it'll be 11,081, I think, is what it'll come out to be. So we're going to type in IP prefix list dash list, and then we're going to end and then config t IP prefix list. IP prefix list, and we're going to say R22. We're going to say permit, and we're going to say permit this route right here. So router 22's loopback. Permit this guy, and then we're going to say enter, and then we're also going to say whack this back a bit, and we're going to say permit 0.0.0/0 LE32. Okay, so then when we go back to do show IP route, as soon as it takes effect, it might take it a minute to do this. We have it's not taking effect. My intention was to take this this metric and bump it up by 200 by modifying the offset list, which it might be an outbound configuration. I've never really played with it. And then we're going to go to topology base, and then distribute list, or our offset list is add or subtract offset from EIGRP metrics. So offset list, and then we called an axis list. That's our problem, an axis list. So we're going to type in do show run pipe section prefix. We'll just copy that information into an ACL. We'll just tweak it a little bit. So we're going to open up Notepad, bring this guy down just a little bit. We're going to type in this guy right here. We're going to say, grab this guy, we're going to click on this, go B, and then we're going to type in, we'll type in no IP prefix list R22. And we're going to type in axis list, IP axis list, we'll say is R22, and then we're going to say extended R22, and then we're going to say enter, and we're going to named axis list. The standard 8 IP axis list with this name already exists. Okay, so what we're going to say is extended. We'll say extended. We're going to say from R22. And then we're going to hit enter. And then we're going to say permit 10.100.0 or 10.100.22.22 permit permit IP 10.100.0.22.22 or permit I'll say 0.0.0.0, so matching explicitly, and we're going to say any, and then we're type in permit IP any, and then we're type in router EIGRP 1, address family IPv4 autonomous system 1, and we're going to type topology base, and then the offset list that we typed in before, type in do show run pipe section EIGRP, and we have this configuration right here. We'll type in no, right click and paste. So we'll type in offset list is going to be, the name of it is going to be from R22, and then we're going to say we're going to perform offset on incoming updates, so in, and then we're going to have the offset is going to be 200. We're going to hit enter. This command only accepts standard IP access lists. Okay, well, I just learned something new. So we're going to just undo what we just did. So we're going to type in exit out of here, exit 3 levels deep on that one. What we're going to do is no IP access list extended from R22, and type in IP access list standard from R22. Go to the end, and then we're going to say permit, enter. We're going to say permit IP host 10.100.22.22, and then we're going to say enter. Permit, what? Permit host, of course I would do that. And we're going to type in router EIGRP 1, address family IPv4 autonomous system 1, and then topology base, and then you're going to see offset list from R22 in, and then the offset is going to be 200. Alright, so now hopefully that'll apply. I'm going to give it a second for it to see if it's going to resync. Show IP route, and there it goes, it resynced. Yeah, it doesn't seem to be taking effect. Although I'm noticing this is 10.880, this is 10.881. So let's do a show run pipe section EIGRP. Did that even have any effect on it? It looks like it's having some effect, because if you look at the show IP route, we have 10.881 versus 10.880. Let's go to global config again and go. Actually, it makes it easier when you just do this, and you go what the. It's a lot of configuration to punch in, but at least it gets you where you need to go. And then the offset, type in no offset list. No offset list from underscore R22 in. So that'll resynchronize here momentarily. Alright, so that did so do show IP route. And it was having an effect, because now the route's back to 10.880. Before it was 10.881. I don't know why that wasn't working though. That makes me wonder why it's not working. So what I'm going to do is I'm going to see if there's this offset list. You can type in Control A and take this offset list and go whack that out, go to the end and type in from R22 out, and then the value of the offset is going to be 200, and then let it resync. We'll see what that does. Now technically that should be out to R22, but we're just going to see. I'm just curious to see what it's going to look like. Okay, so do show IP route. Alright, so now if we go to R22 and we say show IP route, show IP route, we should have I don't see that having any effect. So that's weird. I'm gonna have to look into that one a little bit, and then we'll figure out what's going on with that. Hold on. Just according to Cisco, it's done outbound, and we did that offset list. We'll say from. We'll do this up. We'll go Control no, and then Control A out. Oh, I've never set the outgoing interface gig 1/0. Alright, so there it sets it up. So now let's take a look at, or no, actually no, I'm going to do in. Alright, so that sets it. Okay, so that might be our problem. I'm just never setting the interface. I wasn't completing the command. So do show IP route. So it's having a minor modification to it, but it's not doing the 200 like I'm looking for it to do. So I'm not sure why that's not working. I might have to dig into figure out what the deal is with that. But typically you only add an offset when you want to prefer one path over another when you are having a problem with multipathing. So you would advertise a route. You would use an offset list to, if they tell you not to use the delay or not to modify any of the metrics for EIGRP, this is where that would come into play. So, I'm not sure exactly why that's not working. That actually bothers me because I've used it before. RIP, it's easy because it's just an offset list and you point it. So, but anyway, let's not get stuck on that. So I just wanted to see if there's a quick way to fix that. Now with per neighbor AD, and you have the distance command right here. You can type in distance, and then you could say set EIGRP distance for internal and external routes. So you can type in EIGRP, and then the internal routes are going to be, say, we can say, 90 for internal routes, and then for external routes you can set it for, 110 to make it equal with EIG or OSPF, and that would be all you'd have to type in there. But the distance, if you were to specify the administrative distance, to say by default it's 90, so we're going to say 90, and let's type in 89, and then we're going to say the source IP address of your route. So this is where you're able to manipulate the administrative distance on a per neighbor basis. So we're going to type in 10.1.126.22, and then we're going to say the wildcard bits are going to be specific to that neighbor, and then we're going to say is there an access list we're going to apply to it to specify a particular traffic. We're going to hit enter for no, and that should resync. And we're going to type in do show IP route. So now it should, anything from this guy should show up, and there it resynced. And then now, let's see, there we go. And there it goes. So it resynced, do show IP route, and so anything from 22 is coming in as an 89. So that gives you the idea of how that would work. So that's how you would modify the per neighbor AD. And then you got filtering with route maps. You've already seen how that would go. You would have an ACL, and that ACL would be called by a route map, and then you would apply the route map, and then you would do your match or set statement. So you would drop traffic permit, set a route tag, that type of stuff in the route map. So I'm not going to go into that one at all, but it gives you the idea of how this stuff works. So per neighbor prefix limit. So let's say, for instance, we had a bunch of routes inside of EIGRP that we wanted to advertise here. you could type in, I think it's under over here. I think it's here. Let me do this real quick, and we're going to see view sessions. We're going to go to ESXi. I'm going to go connect to router 1 on this guy. He is a CSR 1000V. I'm going to go connect this guy, router EIGRP test, and then we're going to type in address family IPv4 A1, and then topology base, I think is where it sits, and then prefix limit. No, it's not there. It's got to be underneath here. Prefix limit is it AF interface? AF interface gig 1, and then passive, no. I know you can do it with the prefix list, and you can go in here and you could create a prefix list to match a certain set of routes from router 21 on 16. So you can sit here and go, I want to match 30 routes from this guy, but why? It doesn't make sense why it would have maximum paths. No, that's not it. Exit here, and what are my options? Yeah, see, if it's not on the CSR is usually the one that I go to check things out like that, because it's got the higher IO operating system on it. So I'm not sure where per neighbor prefix limit would come in. Well, actually, I do know. So you would, you know what? Distribute list. That's what they're talking about. So you can go in there and you can specify distribute list and call a bunch of routes, and then through an ACL, and then use a distribute list. So you could limit the prefix limits on that. So if you were to go to topology base again and type in distribute list, and then there's gateway. So filter incoming updates based on a gateway. So gateway, and then you could type in the prefix list. Could be from R22. That's what I was trying to do. So if we had R22, you could say from a prefix list, and it has to be a prefix list. And then you could do distribute list on that, and then you could do it that way, and then you could mention from the gateway. So the gateway would be from R22, and then you would say, we'll say test question mark, and then in, and then you would say specify the interface, so gig 1/0. That would be the syntax, and then test would be restricting a certain amount of routes. So that's pretty much all there really is to it. It's just a matter of going in here and modifying how things actually work and making sure you know what they are. Ultimately, that's our goal here in this section, is to test everything out. And the only one that's got me is offset list right now. And I'm not too concerned about that because it's kind of a corner case scenario, but I will double check. We'll throw that in just to see exactly how things work. And the cool thing about all this stuff is, as we're going through our preparation here, and you guys are watching along or you're trying to do the lab with me or what have you, the cool thing about this is these are going to be labs that, as you're going through, you're going to be reinforcing what you already know. So you're going to be able to say, a lot of times when I'm reading labs, for instance, I'll go out to, what is this thing called? GNS3vault.com. So here they have, let me turn some of this other stuff off real quick. So we have GNS3vault.com. And what this guy does, this is Rene Molinar, he's a CCIE. He created this website. And that's a CCIE number right there. So basically what he does is he's basically he created his own CCIE lab. Actually, another guy named Nick Russo did that. And let's just click on that and see where it takes us. So this is basically what Nick has created, and Nick is also a CCIE. What he basically does is he writes this here, and if we can scroll down a little bit here at the bottom, this is the lab, so the main topology, and then you go through here. He gives you the operating system number, or the name, so what iOS image you're supposed to use, and then he breaks this down as to how this is supposed to look. OSPF, EIGRP, a little bit of RIP in there, I think. No. Yes, right over here, RIP version 2. So you configure this all in here. So you're obviously going to have redistribution. He's going to have BGP, and then obviously he has this guy's a route reflector. And then we have the MPLS topology where we have the PE, the PE, the CE, the CE, and then you have these guys are talking to each other. So as you see, we have the PE to PE routing here. So this will be your VPN-v4. We have 2 provider core routers. So in case this guy goes down, you can reroute, but it really doesn't make much of a difference. Then we have the multicast topology. So actually, let me build this up a little bit so you guys can see this. You have the multicast topology. So you have your PIM source, you have the PIM destination. So basically, what you're doing is you have your AutoRP mapping agent here, and then you have these guys. This is PIM. This guy is running. This would be IGMP because PIM doesn't run against the source. So you'd have all these guys would be running PIM in sparse mode, and then from here you would go in and get everything situated. So you'd have your RP. This guy would be an RP. So yes, the RP can also be an AutoRP mapping agent, so they can be one and the same. And then you would have the RPs being mapped, and then you would come down here to IPv6 IGP, and then we have OSPF. Area 38, 23. So if that doesn't jump out to you as a virtual link, I don't know what would. So you have a virtual link configured between R2 and R3 to get R38 operational, and then that would be the extent of your configuration. So if I'm actually thinking about doing lab 1 and 2 just to see them out. And the cool thing about these labs is they don't configure anything for you. So you literally have to come in here and set this lab up yourself, which is actually good practice because then you don't have the ability to have somebody else do all the work. So it gets you in that mindset of, okay, how would I build it? So that was my mindset with this topology. You get this big topology here. That was my mindset. So being able to tweak this stuff, you should be able to zero in on a problem pretty quickly and be able to figure out what to do. So we're testing all these theories out. So by the time you get to the full-scale lab, you should. When I'm writing a lab, going based on what I've gone through with these, you don't have to go through these labs if you don't want to. They're just here for your help. You should be able to go through and figure them out relatively easily. Not saying they're going to be all easy, but I'm not going to throw you a bone and say, hey, make sure auto summary is disabled. I mean, I shouldn't say that. Some CCNAs don't even know what that is, and they claim to have a CCNA. So if you don't know what auto summarization is, well, that's a CCNA topic. You need to go back and revisit CCNA. So it's one of those things where your level of understanding will dictate how well you will do. So that's just some of the stuff that I wanted to go over with you. So we're going to keep doing what we've been doing when it comes to setting this stuff up. I'm thinking about spinning up these GNS3 labs just to try them out. There's 2 of them here, and I'll quick show you lab 1 because he mentions it in the first one. And he goes over. This is the first one we go through. So all the way down at the bottom here, this is everything you have to configure. And then this is the topology. So this is the physical topology. This is the logical view, and we have everything situated here. So this would be very version 4 specific. And as you can see, he sets everything up the way you need it to, and the different topologies the way you need to set them up, and stuff like that. So it gives you a lot of flexibility with that. So it is very cool in regards to the majority of how this stuff is laid out. And then you have your EGP. So this is the only part that catches me up. So we have AS123, which is going to be, let's see here, we have AS, sub-AS, this guy. So this is a confederation. This looks like a route reflector. This looks like a route reflector. I'm not exactly sure how to make this out right here. I'm not sure what this is. If this is a route reflection, but so you can't route reflect between outside of an IBGP. So sub AS 67 4. Maybe 4 is the. Oh no, that'd be the sub AS 4. confed 467, sub AS 67. Maybe that is the... I don't know. That part's always puzzled me. But anyway, that's what I got going on for you guys in this video. I hope this has been informative for you, and I'd like to thank you for viewing.